Welcome to Learning to Engineer. In this video, we are going to solve a couple of simple problems in the topic of RLC transients. In this video, we have seen the basic concepts of it. We have derived the response of RLC series and RLC parallel circuits. We have also found out the damping conditions of both the circuits. Now, we will apply all the concepts that we have learned earlier and then solve this problem. Let's get started. The question is, a series circuit consisting of a 12 ohm resistor, 84.4 microfarad capacitor and a variable inductor connected to a 100 volt 50 Hz supply. For the resonance condition, determine the current through the inductor and voltage drop across it. Find Q factor and bandwidth. This is the circuit given in the problem. It is mentioned that the circuit is at resonance. So this means that at 50 Hz, resonance is happening. So what is the resonant frequency? The angular frequency is 2 pi into 50. So at this frequency, we are said to have a resonance condition. At resonance condition, three things will happen. One is the response will be maximum. Next is the reactive part will vanish. What does it mean when I say the reactive part vanishes? The inductance will counteract the capacitance and vice versa. Both of them will happen in the same time such that the effect of the impedance is getting minimized. This condition is called as resonance. And at resonance, we have two frequencies. One is the upper cutoff frequency and the next is the lower cutoff frequency. This is the resonant frequency of the curve. At resonance, the response will be maximum, or this current is called as Imax. The 70.7% of this current at either sides is called as cutoff frequencies of Imax. This is called as the lower cutoff frequency omega L, and this is called as the upper cutoff frequency omega U. Okay, and this gap is called as bandwidth. So this is the basic concepts on resonance that we already saw. So now using these concepts we will solve this problem. It's given that the circuit is in resonance. We are asked to find out the load current at resonance and then the voltage across the inductor, then the Q factor and then the bandwidth. It is given that this happens at 50 Hz. Resonance happens at 50 Hz. So the resonant frequency is 2 pi into F, which is 2 pi into 50 Hz, which is 100 pi. So this is the angular resonant frequency of this circuit. Okay, so this is 1 by root of LC, or we can say that the linear resonant frequency will be 1 by 2 pi root of LC. Either way we can see. So this implies that 100 pi is 1 divided by root of LC. We don't know the value of L. We know the value of the capacitance. It is 84.4. So this implies that L into 84.4 microfarad will be 1 by 100 pi whole square. The value of this will be 1.014 into 10 to the power minus 5. So what is the value of L? So this is the value of the inductor. When the inductor's value is 0.12, resonance occurs. Okay, so next we need to find out the inductor's current. At resonance, we have seen that the impedance part vanishes. So what is the circuit's current? The circuit's current will be 100 volt divided by 12. It means that the impedance doesn't exist at all, and we need to find out the current IL of t now. So at this condition, IL of t at resonance will be 100 volt divided by 12 ohm, 8.33. So the current that is passing through the circuit at resonance is 8.33 ampere. This is the maximum current. We have to find out the upper and lower cutoff frequencies in order to find out the bandwidth. Next, we are asked to find out VL of t. What is the voltage across any component? It is the current times the resistance. Since it is an inductor, it is the current times the impedance. IL of t into XL of t, which is 8.33 times omega L, which is 8.33 times, what is omega? 100 pi or 314 times 314 into L. L is 0.12 Henry. So now we have found out this current, we have found out the inductor's voltage. We need to find out the Q factor of a circuit. What is Q factor? Q factor or the quality factor is reactance divided by the resistance. Q factor is reactance divided by the resistance, which is so this is the quality factor of the circuit, and then we need to find out bandwidth. Bandwidth will be the frequency of upper cutoff minus the lower cutoff, and at the mean of these two we will have the resonant frequency. Okay, so since we have the value of Q factor and also we have the resonant frequency, we can easily find out the bandwidth by another formula. This is nothing but the frequency at resonance divided by the Q factor. This gives us the bandwidth. So the bandwidth will be 1 by 2 pi root LC. So this is the value of 1 by 2 pi root LC or the resonant frequency divided by X by R or the Q factor, which is 3.14. So this will be 100 by 2 is 50, 50 divided by 3.14, which is this is the value of the bandwidth that we have got, which is 15.92. We have seen that the resonant frequency is 100 pi and the linear frequency is 50 Hertz. So the graph is something like this, right? So at this 50 Hertz resonance happens. The bandwidth is 15.92, half of which is 7.96. So at 7.96 Hertz from either side of the resonant frequency, we have upper and lower cutoff frequencies somewhere here. What is Imax? Imax is this current 8.33 ampere. 70.7% of this current is the current that is achieved at the frequency of 7.96 lesser than 50 Hertz and 7.96 higher than 50 Hertz. So these are the upper and lower cutoff frequencies. We will now solve another problem in the same topic.